In this session, I'll discuss some of the Professional Edition features, some of which are new to CCDAutoPilot 5. The first one I'd like to talk about is the Filter Focus Offset Wizard. This is a method to automatically measure the offsets introduced by different thickness filters and or different spectral response to your telescope. I have hooked up CCDAutoPilot Professional, in this case, to CCDSoft, the SkyX, Focus Max, and they're really the key elements that we're going to need to do our focus offset measurement. In the focusing window, we see that there are no offsets entered, but I've set the focus exposures for good starting points for Focus Max. These were determined beforehand. Typically, the luminance or clear filter wants to be shortest, the color filters can be a little bit longer, and the narrow band be longer yet. Having set this up, we'll now go to the settings page and the wizard section, and here we have the focus offset measurement wizard. We select the filter that we want to use as the reference for the offset, and most people would use the luminance or your most transmissive filter, in this case luminance. I'm going to do 5 measurements per filter. The specified number of measurements per filter, 5 in this case, must be achieved with the current filter before moving on to the next filter. So at this point, I'm going to start the process. I hit the measure button, point at a suitable focus star near the zenith, which we have done, and we're ready to go. So we just hit the go button. Now you notice on the left side of the window, there's a log window that's kept of everything that's going on. For example, our ambient temperature shows at 17.7 degrees C. Our focus star is at an altitude of 86 degrees. This is recorded at the beginning and end of the session so that if you have an excessive temperature shift, you'll know that. If the star drifts too low in altitude, you'll know that. Based on past experience, in this case of measuring 6 filters with 5 measurements, will take about a half an hour. So what I want to do is I'm going to pause the recording and check back in from time to time. As you can see, however, our first focus measurement is at 12,719 with the red filter. One measurement is complete, and again, we will do all 5 measurements of the red filter before moving on to the next filter. Once that is completed, the median will be calculated, reported in the log, and we'll go on to the next filter in order. As you can see, now the second one has succeeded, and they're fairly close. So we'll pause here and we'll join it in a little bit. We can see we've completed the first 5 measurements of the red filter, and the median focus position for the red filter has been calculated at 12,719. We're now moving on to the green filter. We'll join again when we get a little further along. Our measurement wizard has completed its work. We have measured 6 filters with 5 focus runs each. The offset measurements are complete, and the filter offset values were entered onto the focusing page. There is a log on the Windows clipboard, and you can now bring that log up in Notepad just by clicking the S. And this is the result of that log. Our offsets have been calculated as indicated here, and they were entered automatically into the focus page. This is an example of the Filter Focus Offset Wizard in action. The Professional Edition also has the ability to be controlled by an external single-line text file. This text file, which can be written by any operating system, Windows, the Mac, OS X, or Linux, can do a number of things that an operator could do during the course of a session. The operation of the single-line text file can be best illustrated by looking at the included control file editor. Here I have the Start Session checkbox checked, and you'll notice up here there is a Y in this text string. When it's unchecked, the text string changes to N. So if I have my session started, I can pause the session, just as if you push the pause button on the session window. This would then resume the session. I can abort the session. I can abort the session and shut down the system as in a weather event, such as closing the dome, parking the telescope, warming up the coolers, and so on. I can also elect independently of the notification tab to send emails for certain events, and I could even include a test message. For example, if my observatory were controlled by the M1 OASIS system, I could put this in there as an indicator, and this test message would be appended to any email notifications. Let's see what this text file would look like. I'm going to save it now to the desktop. I'll save it as test to the desktop, and then we'll look at it with Notepad. So here we can see that there's the single line test file, the various Y's and N's, and our test message we added to the end. Next, we need to tell CCDAutoPilot 5 where the single line control file is, so we use the control file path button on the control settings to navigate to that location. In this case, we would navigate to the desktop and select the file we just wrote there. And lastly, to have the control file specified in this path be used by CCDAutoPilot 5, we must return to the setup page and check the Use Control File box. And so, with this setting completed, the single line text file can control CCDAutoPilot's running session. The single line text file syntax is fully documented in the help file. In addition to weather monitoring by the cloud sensor, CCDAutoPilot 5 Professional allows the session to be aborted if the humidity exceeds a certain value or if the wind speed exceeds a certain value. These are unique features to CCDAutoPilot 5 Professional.